All right. Thanks for showing up, everybody. Hopefully we can teach you a thing or two. We're going to give you a general rundown of Asyril's product offering, and then my colleague here, CJ, is going to give you a demonstration of setting up a recipe with I+, and basically everything required to get started using our system. I didn't start with this, but I'm Connor Hudella. That's CJ. So getting started. CJ and myself, as well as Josh and Taylor, are the 4 support staff in our Edina office. Asyril is a Swiss company. That's where we're headquartered. That's where all of our inventory is kept. We have a support office in Edina, Minnesota, where we support our U.S. customers, answer support-related questions, run feasibility studies free of charge. So if you guys have any applications that you're looking at automating or running with our equipment, can just start an email conversation with one of your sales guys here at Mechatronic, and they'll choose whether or not they want to send us the part depending on the complexity. As you can see, they have a lot of equipment here, so they do a lot of in-house testing themselves, but on occasion they'll send us some parts as well for some validation. The fifth name here that you're seeing, Tony Arquish, he's our North American sales manager, located in Switzerland, but he's our fearless leader, I guess I'd like to call him. These are some useful resources that typically can answer a lot of your questions before they get to our level, but we're always available for questions as well. We have our Asyril homepage. This just has some general information about Asyril. Video trainings, things like that can be located on the Asyril homepage. Our file exchange is just some general marketing information. Additional information, a lot of it found on the homepage as well. Our configurator is more of a sales tool where we build bombs and whatnot for understanding price and things like this. Our sales.us@asyril.com inbox is the inbox for all sales related questions. Support.us@asyril.com, that is in the shared inbox between CJ, myself, and Josh. This is where we answer all support related questions. So if you have any complications during setup or just general questions about Asyril, that could go to the support.us box. Feasibility.us@Asyril is the feasibility testing specific inbox for, once again, CJ, Josh, and myself. So that's where we handle all of our feasibility work and ask that we have requests sent for testing. And then our doc.asicube@Asyril and our doc.I+ are fully online searchable documentation for our equipment. So the ASICube is the flexible feeder table itself. You can kind of see it there next to the Mechademic robot. And the I+ is a smart controller and a camera up top. So that kind of rounds out the package and acts as a control system for the ASICube specifically, helps you optimize cycle rates. We have a lot of nice built-in tools that CJ will show you that make it easy to get started, make it easy to switch over products, and make sure that your cycle rates are as quick as they can be. So what is flexible feeding? I would assume that most of you already know this, but figured I'd toss a slide in there just in case. We're trying to separate parts from bulk. So in any process where you have bulk parts that are coming in on a hopper or a larger feeder of some sort, maybe you're getting them from a customer in bulk, maybe your customer is getting them from a customer in bulk, and they need to separate them for automated processes. There's really 2 methods. Bull feeders are pretty big in the game. A lot of folks use bull feeders. They're really high speed, very application specific. They can typically only run a couple of parts, and they typically need to be retooled if you want to change over. That's where we came, or where Asyril started. Our CEO developed the ASICube for the watch industry for feeding delicate parts, as well as hard to feed parts. So we like to think that it's designed for many parts, small and large parts, and parts prone to jamming. If you use bull feeders, you know that jamming is a pretty consistent thing that you'll see, especially with difficult to feed parts. And at Asyril, we try to avoid this scenario. We also make it easy to accommodate a large SKU of different parts. That's where we specialize, as well as small parts. Like I said, we are a Swiss company that started in the Swiss watch industry. So small parts are really our expertise, I would say. Asyril solution is the AsyCube. The hopper itself here on the end, called the Asyril, separates the bulk parts onto the AsyCube. The AsyCube is responsible for agitating the parts, vibrating them, getting them into a desired orientation. And then the camera, I+ control, is actually controlling the fill level of the AsyCube. It's making sure all your parts are centralized, evenly dispersed, and then it's sending a coordinate to your robot for pick and place. So as you can see, it'll snap a picture, it'll collect its coordinate location of the part, and then it'll send that information to the robot, and then it basically just rinses and repeats that cycle so you can continuously have a production run.
Think that slide?
You like that slide?
That was impressive.
Not that talented. I didn't make that slide. So our AsyCube series, as I told you before, the AsyCube is the vibrating table itself. We have various different sizes ranging from small to large. These smaller sizes are where our company started, the AsyCube 50 and 80. We use those in the Swiss watch industry to feed ruby stones and watch mechanisms for watch assemblies. For Rolex, actually, is who we originally partnered with to develop these systems. And then as we came to the United States, we got bigger and better. So we got the AsyCube 240, 380, and 530 to support those larger applications. All the tables work in a similar manner. They all work with voice coils that vibrate the table and allow you to have 3-axis manipulation of the parts. So you can move the parts forward, backward, left, right, adjust the amplitude in which they flip or a jump, I guess. We like to think that we can feed just about any part. This is why we do feasibility studies. We would like to do our best to prove that your part can be fed and automated using Asyril system. So as you can see here, this is a large skew of different parts. And in the old days, it would take 28 bolt feeders to align these parts for an automated process. With the AsyCube systems, 3-axis vibration, we can do that with a single system. Can feed all of these parts without issue. So this is kind of just an example of our 3-axis manipulation. As you can see, the voice coils, there's one in each corner. We're able to manipulate all types of different parts and control their movements to do just about anything you need to do. A standard application will be that pick and place application where you're locating your simulated parts and then you're collecting a location and driving a robot to grab and place them into your next process. Or pack them, do whatever you may need with them, basically. We offer a wide array of platforms. We have some standard platforms that help us that we've found to work with the majority of parts. We also offer custom platforms in scenarios where you need, let's say, custom holes. Oops, wrong button. Let's say you need custom holes or 3D pockets like this. We do custom platforms. We work with you to develop a custom platform that will work for your application. And then these other ones, our flat platform is our standard platform that we use for most scenarios. Our group platform, these can be customized in any way you'd like for bolts or rivets, whatever you need to fall into a groove. Anti-roll is another standard platform that we use for round parts to prevent them from moving around after a vibration interval. Settle or stabilize quicker. And then the anti-stick is a useful platform for flat parts that have a large surface area that might not move very well on a flat platform. And then we also offer black platforms for transparent parts. We have a polarized platform as well for transparent parts that allows the vision to see them more accurately. Moving on to the I+ Smart Control. So as I said before, I+ is more than a vision system. It's a smart control system developed specifically for the AsyCube. It will guide the robot while managing the AsyCube's vision and hopper behavior. So it makes sure that the platform is always optimally filled. It tells the hopper how long it needs to vibrate to fill to a certain limit. And it also sends the coordinates to your robot. So it kind of operates as the single hub for communication with your entire flexible feeding system. So it controls everything that is within that envelope. Obviously, the robot's going to need to drive to some other location to place the part in its assembly or package wherever you may be going with it, but I+ will control all of its movements related to the SQ. It also comes with a nice intuitive web-based interface that CJ is going to walk you through here in a bit. And then we have some tools built in that make it easy to set up. So we have a robot calibration wizard, vision calibration wizard, and then a recipe creation wizard that steps the user through a few steps to get them to a final result. Makes it easy to calibrate your robot and your vision, etc. This is an example of I+ smart centering. So like I said, I+ is a smart control system. It's actively monitoring the platform to locate the center of mass of these parts. As it locates the center of mass of the parts, it is going to attempt to move them towards center, because at center is where we don't want parts near the edges. Those typically are going to be robot no-go zones. And to increase your cycle rate, or make it as quick as possible, we want the parts as accessible as possible for your robot. And we found that getting them towards the center and dispersing them, that flip move is typically the best route. Obviously, that's specific to the type of platform and application that you're on. Smart feeding from the hopper works in a similar manner to the smart centering of the platform. The hopper is going to continuously monitor the platform fill level. So as the platform starts to get empty, you're picking parts from the system. The hopper is going to understand this fill level based on the part size that you've programmed, and it's going to run itself or tell the hopper to run for a specific interval of time to optimally fill your platform. Some advanced tools that we have with I+ include multi-feeding. Multi-feeding allows you to run up to 4 separate parts on a single ASICube platform. You can run it with up to 4 separate hoppers as well. This just allows you to run maybe a full assembly in a single ASICube. You can pick and choose if you want 2, 3, or 4 zones, whatever your application may need. But we feel this is an ease of use tool, so you can do all of your programming on a single ASICube. One thing to keep in mind is that it's only available on the 243 and 530, so those larger ASICubes. And another thing to keep in mind is that all the parts on the platform are subject to the same vibrations. So they need to behave in a similar manner, or else they might not work well together. Additional feature that we have is also multi-model, similar to multi-feeding, but just a little bit different. This tool was actually developed to allow you to pick a singular part in multiple orientations. So when you're programming a vision recipe, you're teaching the system what a good part looks like. You're creating a box that it lives within. This tool allows you to expand that box and accommodate multiple different orientations of a singular part, which we found to increase cycle rates. So you have a kitting operation where you don't necessarily care about the orientation that the part is being picked in, or you can pick it from multiple orientations and place it into your assembly. This is a really useful tool to use. And this is just a comparison between the two. If I've done a poor job of explaining, I guess, at this point. The final product offering by Asyril is also one of our newest products, Asyril Smart Hopper. As the bullet point at the top says, we consider it smart because it has amplitude regulation, and a standard hopper. I don't know if they have any here, but our standard hoppers were previously purchased through a third party called RNA. They're a less sophisticated hopper. They would you set them for an amplitude, and they would run that amplitude for the life of the hopper bin. So as your parts get fed out of the hopper, the amplitudes start to affect the parts that remain differently, making your feeding inconsistent. And we found that in specific applications, that feeding inconsistency causes the platform to become overcrowded. So what we've done is integrated a MEMS sensor within our hopper that constantly monitors the fill of the hopper and returns that information to the system to then reduce the amplitude and maintain that consistent dosing of parts onto the system. So we have various different sizes for different size parts, different size production rates. And there's some rules as to which sizes will fit into which systems. So if you have any questions about Asyril or what size will be best for your application, just let us know. And then this is just a little bit of a competition summary before I let CJ take the stage. Asyril has a patent on our 3-axis separation technology in the United States. So that makes competition a little bit difficult. Competitors can't sell products that are able to manipulate parts like we can. We do blank label for Epson and Omron. So you can get our feeders through their package, but you use the separate vision system. You use Epson's vision system or Omron's vision system. We like to think that the AsiCube is the most compact, flexible feeding system. Has the smallest footprint. It's the easiest to fit into most applications. We maintain a short lead time, although we're sending things from Switzerland to the United States. Typically, most goods are available within 4 weeks. We have local support in the US. CJ, Josh, and myself are always available for communication or questions if you have any. And then we do free analysis and free testing of your parts if you're interested. And then I+ makes the system easy to communicate with and easy to implement. You don't have to worry about communicating with the AsiCube separate from the hopper, separate from the robot. It really marries the whole system into one integrated control. So that's all I have for you right now. Let CJ take over and tell about how to create an I+ recipe.
Yeah, we'll just go through a simple I+ recipe really quick, just to show you guys how easy it is to create one. So I've got this up and running demo here. Typically, when you create a new recipe, you can create a standard recipe with one part, or there's dual feed, which is now multi-feeding, so you can create up to 4 parts in one recipe, or multi-model, which is up to 6 parts on the same platform. But we'll just stick with a standard 1-part recipe for demonstration purposes. So there's 7 steps here that you'll go through in the I+ recipe wizard. And the first step is image acquisition. So this is going to light the backlight and run through 30 different images at different exposure levels that you can set. Right now it's set to 1 millisecond intervals, so from 1 millisecond to 30 milliseconds on the backlight. And if you have a front light, it'll also run through the front light at 30 exposure levels as well. This one right now is set to a 5 millisecond interval, so from 5 to 150 milliseconds. And that's just capturing images for us to go through and use for the rest of the recipe. So candidate detection is the first layer of the vision filter that we're trying to pass these parts through. So I've gone ahead and sectioned off parts in a good orientation and a bad orientation. So these are all parts that that I've set up in a orientation that we'll define as good. And then these are all parts that we've defined as bad, just for your reference moving forward. In this step, what we're trying to do is make sure that the vision can detect all of the parts on the platform and make sure that we've essentially identified all the parts here. It doesn't matter orientation right now, as we'll get through filter. We just want to make sure that we've got all the parts here. And so we can look at this view here, and all of the parts that I+ is detected are in green. And if we look here at the segmentation view, we can kind of take a look at the black and white image that we see, and that the vision system will use. And we can kind of see some noise up here, some noise down here. And so in the advanced options, we've got our segmentation method here. Essentially what this does is it looks at the pixels around all of the other pixels. So it'll go through and look at the difference between the surrounding pixels, and that's how it's going to determine a part. So if we increase this difference level here, it'll essentially increase that threshold that we're looking for and get rid of some of that noise here. And so sometimes if you've got a slotted platform or too high of an exposure level, you'll pick up some of the platform edges as a part. It'll define it as a green zone. And so we want to just make sure that we only have the parts on the platform. And we can create a noise filter here to remove any particles on the platform. We'll just go like 15 square millimeters here. And what that'll do is just remove any of small particles from being detected on the platform. So each step is going to have a results tab, so we can see essentially the results from the step. And at this part, you can create a part size filter. So this is the first filter step in the vision system. So as we see here, I+ has automatically detected that these parts are smaller than most of the parts on the platform. And so it's going to filter those out by size. And so this step is really quick and creates a faster vision result. So if you can filter out a good amount of parts that are in a bad orientation by size, this is that first step here. The next step, step 3, is our AI algorithm. And so essentially what we're doing is creating an AI database and having all of the parts that are then detected in our production run through this algorithm here. Now we can kind of zoom in here and see that it might be a little bit difficult to detect differences here. And so you can select different acquisitions from those images that we took. So if 15 milliseconds works for us, we can continue to use this, and we recommend trying to use the same lighting settings throughout the recipe as is less images to use. Or you can use a different image. Say we wanted to up the exposure level and try and get some more part definition here and some more stuff from the backlight, we can. Otherwise, you can also use front light camera to get another image, and you can change exposure levels here. Kind of, it's hard for me to see at this angle, but do you think, what? I can't see it on my screen. Does that look like there's enough? Okay. So we'll just leave it at that and try it out. So the next part is essentially taking a bunch of pictures of parts on the platform, and we'll then sort them by good parts. So the way I typically do this is I set a bunch of parts on the platform in the good orientation and take an image. You need 50 parts to be able to run through the next step. So take an image, move the parts around on the platform so that we can get a broader range of parts and images. Then take another image, should be at 28 now. And then I'll flip them over into the bad orientation. And because we filtered out by size 2 of the orientations already, like on its side or vertical, we don't need to account for those in here because they're already removed from the last step. If they weren't filtered out by size, you would also need to account for those bad parts. So try and make sure that you cover all of your incorrect orientations in this as well, so that the AI can properly detect bad parts. So let's go through this. Sorry. Right. Take another image. So like I said, you need 50 to move on. However, if you would like, or it's a difficult part to tell with the lighting settings that you have, you can take more images and train the AI algorithm further. For now, we're just going to start classification, and it's essentially Tinder, but with parts. You swipe right for good and swipe left for bad. That was a good part. So the first 28 parts that we took pictures of were good parts. So I'm just going to move them all over into the good side. And this is typically how I like to train my I+ recipes, as it's easier to and quicker to just move through all the parts at once. So then 27 and 28. So now these are bad parts. So we're going to move them all into the bad candidates. The AI algorithm, this step, the candidate selection step, after 15 parts of each good and bad, it'll say, okay, enough candidates classified. It feels comfortable with making a classification, but you can always add more to boost the robustness of this step. So I'm just going to continue filling in all the parts, categorizing them. And so then we can apply classification and it'll move to the results tab. And we can now see these parts that were previously in green from the last step have now been filtered out. And these are all good. And you can see the confidence level here. And so we see 96.2% is the lowest one. And then the next one is 5%. So I feel pretty confident moving forward with this. Obviously, if things are a little bit closer, you can train the classification a little bit further. Now we're going to move on to the pick point teaching step, where we're now teaching where we want to pick this part from. And like all the other steps, you can select a specific acquisition setting here if you would like. We're going to stick to 15 here. Yeah, just going to stick to 15. Right here, you have to put in the part's height. This is to account for parallax. So if you've got a taller part, something that has a little bit more extensive parallax, you want to make sure that this part height is as accurate as it can be, as I plus will account for parallax and place the pick point where the actual pick point should be. I don't know, these are probably 5-ish, maybe a little higher. And then the production plate height is filled in depending on your cube size. So 13 millimeters is standard for 240. If you create your own production plate and it's higher off of the platform, you can adjust this as you see fit. Yeah, so moving in, I plus is going to create this outline around the part here. And it's going to try and match this outline to every part that gets to this step, and match a pick point to it. And so we want to mask features that are either not on the plane of picking or are unimportant to us. So right here, we can probably mask out this right here. It's unimportant to us. This right here is also unimportant to us. Could probably even mask out some of this stuff here you'd like. Kind of just takes a little bit of practice to get used to what you need to mask out. So then you can mask this and it'll remove it from the outline. So if we go here, we've now not outlined any of the stuff that we've masked, and we can place a pick point. It'll automatically place this pick point in the center of mass. So where the center of all the pixels are, it's going to place. But we've got different geometry features here that we can use to center pick points as well. So we've got a square box that you can adjust here. We've got a circle as well that you can adjust as you see fit. And then we've got a perfectly horizontal and a perfectly vertical line. So we're just going to place it on the center of the circle here. I really cannot see that well, but I think perfect. So you can see it'll snap directly to the center of that circle there. And so if we go to the results tab next, we can verify results here and just check and see that everything's centered. So like I said, it's going to try and match those match that outline to all of these parts. And if it doesn't score high enough, it'll also get kicked out. So this is another filter step. This is really good for parts that are mirrored on one side. So say you've got like a bend like this, and you want to pick it only from this way. If it's flipped that way, the outline won't match, and so it'll kick it out. It's a really good use case. You can also adjust the score threshold here. So if you want to make it a tighter threshold or a little bit looser, you can. So yeah, that's that. Feel free to stop me in the middle of this if anybody has questions as well. Please interrupt or tell me if I'm moving too fast. So the next step is pick angle. So we want to define the angle at which we pick. So when I plus sends coordinates to the robot, it's going to give a rotation as well, and that's where the part is angled on the platform. And so we want to be able to define the angle that we want to send. And so this is where you would kind of set your robot's X, Y axis and rotation and how you want to essentially center that. So we have the feature masking here as well. So we'll need to do the same thing. What's really nice is if we want to use that same outline that we have in the previous one, you can import the mask from PickPoint Teaching. So if you hit import PickPoint mask, it'll import everything and we'll have the same outline. It's typically what I do unless there's some certain feature that I want to be able to use to clock the pick angle. So if there's something on a top feature that you want to be able to mark as your pick angle, you could do a separate mask here. Yeah, I guess for this, we can try and line up this horizontal line right there and move, and it'll snap to that horizontal line there. You've also got this line tool too. So if you want to create a straight line somewhere, anywhere else, you've got that ability as well. Yeah, so I guess another advanced option to do, oh, it's not on here. You can pick apart from multiple angles. So if you've got, say you're picking washers up and they're circle, so you can pick it from anything. Or you have a part that's mirrored, you can have it repeat angles. Or if you don't care about the pick angle, you can skip this step entirely and it'll just send the same RZ each time. So we'll just get rid of this. There is also an angular limitation here as well. So say you don't want to pick from a certain angle, say your robot can't rotate that far, or you want to make sure that parts can only be picked within a certain range, you can add an exclusion range here and that'll filter out parts. Otherwise, it'll try and match that mask the same and provide a confidence score here, and you can adjust that threshold as such. So here we can see that it's picking pretty well, clocking the angles and everything. So the step worked. The final vision step is setting your gripper drawings. And essentially what this is doing is creating an exclusion zone. So we've got circles for vacuum grippers and boxes for finger grippers. This one will use a finger gripper. You can adjust size and it'll give you size in millimeters after you complete a vision calibration. So you can accurately size up your gripper however you want. I don't really know. We'll just go with like that. Sure. So then you can lock it on to the middle of where your pick point is and do that. And so this exclusion zone will designate this part as not pickable if there is another part detected within this range here. And so that's to avoid gripper collisions and robot collisions. So we'll just create another one right here. Again, can't see, so I don't know if these are matched up. They look good to me. You can also create picking limits and adjust picking limits here. So this is, again, for gripper collisions to avoid. If that gripper exclusion zone that we just defined in this step meets with this red box here, I'll bring this in because that'll show it. It'll designate it as not pickable either. So if we go to the results here, and you see this one is marked in red, it's because that gripper is overlapping the bounding box on the platform. And then the rest are highlighted in green. So yeah, well, you can adjust this as you see fit depending on your application. Make it as tight as you want. And that's it for vision. You've now got a vision recipe set up. I+ will be able to detect and send part coordinates over. Super, super easy. I mean, we did it in 20 minutes. The last step is configuring your ASYCube. So the best way to do it is to adjust all of these values. So you can adjust the ASYCube vibration amplitude here. from 0 to 100%. You can adjust the frequency. The frequency range for the 240 is 40 hertz to, I believe that's 70 something. So you can adjust it as you see fit. It'll fill in default vibrations. And these typically work for most parts. And you can adjust the duration as well. And this is for smart centering and its capabilities. So when you adjust this duration here, it'll, this duration, I guess I should start by saying the duration is from one side of the ESI cube to the other. And what smart centering does is it takes that center of mass on the platform and says, okay, we're this far from the center. And so I know how far or how long I need to vibrate for to get from one side to the next. So then linearly, I need to vibrate, say I was halfway, I need to vibrate half of that time to move it to the center. Does that make sense? Okay. And so you would go through and tune all of these features here. This is all of the different directions and a flip. And then these are our cross centering and long centering features. So if you want to move parts to the middle like that in a flat way or like that, that's what these two functions are for. You can also import vibrations as well from a previous recipe. So if there's parts that act or behave very similar on the ASCII cube, you can import those vibrations directly from a different recipe and simplify this step as well. So I'll just do a quick test here. Maybe increase this to 70. It's down to 64. See how 2000 is, and we can test the vibration here. So when I hit test vibration, it'll move parts across the ASCII cube. That seemed to work pretty well. You can also test the vibration continuously. And so when you do this, it'll turn on until you stop it. So yeah, you would go through each of these four here, tune them so that smart centering is as accurate as possible. We can tune our flip here. I'm just going to make sure that they don't fly out. Yeah, that seemed okay. Yeah, so essentially that's vibration tuning. You can always restore to default too if you need to. Next step is hopper tuning, and this is really useful for smart centering. So our new Assyfill hoppers are analog output, and so you can directly control the amplitude here from I+. The smart feeding settings are optimal number of parts. So you put however many parts you think is the best on the platform. That'll take some time to get used to. Typically it's around 1/3, or you can line up parts from corner to corner, and that typically can be a good indicator. It'll just take some feel to get used to. For here, I don't even know that. 14. So we got about 15 on there, 14. And then you set how long it takes to deliver 15 parts onto the platform. And so we'll just say 600 for now. And what this will do is it will, when I+ images the platform, it'll actually count how many parts are on the platform and say, okay, we've got 6 parts on the platform, but we need 15. I know to fill the platform with 15 parts, it takes 600 milliseconds. So then you can do a linear, it'll do a linear calculation and fill 9 parts on the platform by vibrating a certain period of time. Yeah, any questions on ASCII cube tuning, hopper tuning, smart centering, smart feeding? Good on that? Okay. Last step is creating the vibration sequence. When you are programming a robot with I+, super easy, and the typical command you call is get part. And when I+ receives get part, it automatically takes an image, determines the center of mass of these parts, and uses the smart centering, if you've got that in your sequence here, smart feeding to fill in how many parts you need on the hopper, take an image, and send a part coordinate back all automatically. The only programming that you need to do is actually call an I+ function, get part. And so that vibration sequence here is what's performed when you call get part. So typical vibration sequence includes a smart centering feature here, a smart fill, a smart centering, a flip, and then a delay, a rest, settling period. This value will change depending on your ASYcube parameters here. So I believe it's the longest one is 3,500. And so it takes half of that to get to the center. So as you optimize this centering feature here, this time will become more accurate, if that makes sense. And same with here. And this is the maximum time that it's going to take. Typically, when you're in production, times are going to be a lot shorter than this because parts are already on the platform and they're not going to be super far off to the side needing to come over. It'll just be a short vibration. You can then determine how long you want the ASYcube to flip for. We'll just go like 400 seconds here. And this will use the amplitude and frequency that we set in the platform tuning. And then the settling time here can be adjusted as well. You want to make sure that the parts are all resting on the platform before image is taken so that you get as accurate of a pick point and pick angle as you can. You can also add certain moves. So you can do cross centering, long centering. You can also do any four of the directions here if you want to manipulate them in any way, shape, or form. And you can test this sequence out as well. So if we run sequence here, it'll take an image, vibrate them, take another image, and go through essentially the vision algorithm all automatically. So this would be equivalent to your get part. Yeah, and it'll show you how many pickable parts you got and that kind of stuff. So all you have to do is save the recipe, and this is ready to go. You can start production using the recipe ID here, and start using I+ commands. And so your vision recipe, your ASYcube vibration is all done internally through I+. Connor will talk more about integration and how to actually use these commands now. Were there any questions about setting up recipes, any application-specific questions that you guys might have? No? All right. We will continue the presentation then.
Right. Since every application is different and everybody's working with a different type of communication, I'm just going to try to cover the communication in both. Best ways to communicate and kind of that getting started, that get part scenario that CJ was talking about. Obviously, that's going to vary based on your form of communication, field bus, TCP, IP, or Modbus TCP. But that's what I'm about to go over. So I+ communication, I+ natively speaks TCP IP. I would say that's the easiest language to program with I+, but field bus is also pretty straightforward. It's basically taking all of our TCP IP commands and translating them to a field bus module that can be installed in the I+ controller. But natively speaking, TCP IP production scenario is going to look like this. So you're going to start production with that recipe ID that is created when you finish your recipe. The robot needs to be out of field of view, obviously. When the robot's out of field of view, you can call that get part. What this is going to do is image the platform, complete the vision analysis, and it's going to identify where the good part positions are. Once it identifies the good part positions, it's going to send those coordinates to the robot one by one. I+ is going to store a queue of them. If you're interested, you can collect that queue so you can do the counting on your robot, or you can just rely on I+ to store that data for you. And then every time you say get part, it's going to give you the next variable in that list. So you're basically just going to rinse and repeat that scenario until the platform is empty. And then once the platform is empty, you're done with your production cycle, you can change over, refill your hopper, do whatever you need to do. Some other basic commands that will go with a start production, get part, are stop production, obviously. You gotta make sure when you're finished, you're stopping production. I+ is going to display whatever state it's in. I believe there's somewhere near 32 different states that I plus can be in. It'll say that specifically on the I plus homepage. You're in the incorrect state, not the ready state. You can't start production. So you gotta make sure that you're already stopped production, so then you can begin production. That's pretty common getting started problem that we see. And then the final basic command is prepare part. What prepare part's going to do is, as soon as you know that your robot is out of the field of view, you can call the prepare part command. What this is going to do is, the idle time when your robot's away, is going to collect more information about the platform. If there's a part in the I plus Q from your get part command, it's going to have that coordinate ready for when it calls get part. If the queue is empty, it's gonna know that the queue is empty and it's gonna say, hey, it told me to prepare a part, my queue is empty, the robot's away, I'm gonna vibrate the platform, collect another image so that when the robot's ready to come pick again, I have another part in my queue, so I'm ready to go. We also have some more advanced commands in our documentation for scenario specific application questions, I guess. We also offer field bus communication for the iBus controller as well. So we have Ethernet IP, EtherCAT, and Profinet. Those are all hardware modules that, those are all hardware modules that need to be ordered from factory. They're installed into the controller for field bus communication. As I said, we support all of the major brands, we like to say, but if you have any questions about other brands that may not support it, please let us know as we are developing more tools for future use. iPlus also supports a handful of different robot manufacturers. These are standard plugins for standard applications. They're single part, single IDQ, single controller applications. You have scenarios where you want to use a single robot and 3 iPlus devices. These plugins don't support that scenario, but they can be manipulated to support that scenario in some cases. But it's good to keep in mind that they're designed for that standard process. The as-you-choose communication works similar to the iPlus communication. If you choose to use a separate vision system than iPlus, Asyril supports all the major field bus languages once again through gateways. So that the ASICube itself natively speaks TCP/IP and Modbus TCP. It's vision agnostic. You can use any type of robot you want, any type of PLC, as long as it supports one of those field bus languages. And iPlus controller and the ASICube are considered slave devices, so they need something controlling it, whether it be a PLC or a robot or a PC. That is a requirement for the system. Similar to the iPlus controller, we also offer a handful of plugins for major robot brands. Once again, these are those single feeder, single part applications. Adaptations may be required, but we support the following for robot plugins. These are easy to get started. They have all of our commands pre-programmed in. So you basically just download the plugin, install it onto your robot. Make sure you're communicating, and then you can start a production cycle rather quickly. And those are major communications talk about inside Plus and Asyril. But if you guys have any Mechatronic specific or Mechatronic specific questions, I think Austin might be able to help you answer. You guys came to see the Mechatronic as well, so.
How about if you go over like the calibration process?
No, but I can do that really quick.
Yeah.
It's super easy.
What tools that we have on
Yeah.
the web interface.
Where's my mouse? Oh, it's not plugged in. You're losing your pointer out. That's okay.
This,
No, I was gonna use my mouse. Yeah, so there's a vision calibration that you perform when you first purchase your iPlus controller. It comes with a calibration plate, the camera, and the iPlus controller box.
Yeah, right.
So you would set that in lieu of a platform here. We can actually go ahead and way through it, yeah. So under the configuration tab, you've got a bunch of different options for settings. So you've got communication. This is where you can change the IP address of the I+ controller configuration port that you directly connect to. It should be noted that this is a web browser application. So all you have to do is connect your computer to the I+ controller through the configuration port and type in the IP address of the I+ controller, and you're in. No software needed to download. It can work on Firefox, Microsoft Edge, Chrome. I'm using Chrome. There is also an AsiCube specific controller as well. So, but that is an application called AsiCube Studio. Essentially, AsiCube Studio would be used as the last step of the I+ recipe if you're using a separate vision system. So you would program a specific sequence for your part on AsiCube Studio that's saved in the AsiCube itself, and then you can use that recipe or that vibration sequence separately. So like I said, there's communication. Vision here, this is where you're going to find your camera configuration wizard. So this is the first step that you would do when you're setting up your I+ device, is perform a camera configuration. It's a wizard, just like the I+ recipe, that will step you through the procedure. So you can mark front light, back light, depending on what you have. And then you can set your aperture as well. Want to make sure it's about 5.6. Then you tighten the set screw to stop it from moving. Next step is hardest part, where you have to center the camera in frame. I lost my mouse. So if we do the backlight, you can turn it on. We had just moved this from a trade show. So every time you move the I+ camera or move the whole unit, you should probably redo vision calibration, as things will get moved. So you can see it's not lined up here, and yeah, we'll leave it for now. But you would essentially center it in between these four circles here, right about here. You then define the AsiCube orientation so that we know what we're looking at here. So I do backlight again. This is the connector side. You can also invert the camera. We're not going to, but essentially if we wanted to invert the camera, we could. We also have mirror support. So if you're trying to have a more condensed automation cell, we do support mirrors. So if you want to have the camera looking like this and then have a mirror facing down at the AsiCube, we support that as well.
One thing that we haven't mentioned is the I+ works at each AsiCube size has 2 separate fixed lengths. So we can either do a short or a long, and we have lenses specific to each system that work with that short or long focal length. So that's already part of the package. You don't have to go searching for the specific lens for an application or a specific camera. That all comes with I+.
Yeah, and this is the short working distance for the 240, just for reference. You can then adjust your focus on your camera. There is a focus gauge here as well to make sure that you're in focus, which we currently are. You'll then measure the actual working distance, just to make sure that I+ knows exactly where we're at. And then you perform the vision calibration, and it's going to go through and take pictures, do this automatically, and then you're done, and it'll provide you with results. So it'll give you an RMS error here, and then it'll also translate pixels to millimeters. So it'll show you how many pixels per millimeter you have, and that's how it translates the coordinates from pixels to millimeters for your robot coordinates. Yeah, that's vision calibration. Should be done at first setup. We're gonna abort camera calibration. Normally you would save it. We go back to the configuration. We've got the AsiCube tab. If you have a purge, you can enable it. Essentially, that is a flap that opens up and allows you to purge all the parts off of the platform and/or hopper. You can see the firmware version, IP address, the port it's working on, all that good information that you might need. Then you've got your robot section. This is where you perform your hand-eye calibration. And so this is how we can essentially translate the millimeters that we've determined or change coordinate frame from I+ to robot coordinate frame. The wizard, again, 7 steps. You have to have a recipe created first. You don't have to do the AsiCube vibrations, just vision up until pick point step, so the 4th step. Once that 4th step is completed, you can perform the robot hand-eye calibration. It'll walk you through everything. So you get a part in the gripper, move it to a corner, you determine the robot coordinates, enter them here, remove a robot, and then take a picture. And it'll translate the actual part coordinate into robot coordinates. You do that 4 times, and then you get results. You do it in all 4 corners. And then it'll give you a calibration accuracy here.
And the nice thing about that too is you don't actually have to teach the recipe on the parts you're gonna pick.
Mhm.
So this part that we're picking is a specific calibration plate that we made, just so that we can easily kind of find it on the AsiCube and get an orientation.
I would recommend doing that too if you're looking for best accuracy. Find something that you can, or create a part, calibration specific part that is better for that than picking a
So this
part in the section.
we designed to center on our gripper,
Mhm.
open it so that we know we're always kind of dead center.
We also offer advanced commands that allow you to automate the calibration process. So if you are able to accommodate a part on a pedestal in your application, you can teach your robot where that calibration part lives. So it can go and grab it, and then you can automate the entire procedure of placing of the part in each of the 4 corners and collecting an image. So then the calibration process is completely automated. You can run it at the beginning of a production setup or beginning of a production process just to make sure your system's under control.
And then you can validate it as well. You can restart it or save it. We're just going to abort. And that's essentially it. Once you've got a recipe, your vision calibrated, and your robot hand-eye calibrated, you're good to start production and picking parts and placing them. Yeah, I believe that is all that we have. Yes, with 2 robots. The hand-eye calibration only provides part coordinates to 1 robot reference frame. So if you wanted to use 2 robots, you would have to translate the part coordinates into the second robot's coordinate frame.
So the easiest way to do that is we'll actually have it, but sometimes you don't do the robot calibration. So instead, the robot or the I+ system is just giving you the default robot coordinates. So it's going from basically the origin of the AsiCube, and then instead you just calibrate each robot to that origin separately. Otherwise, if you calibrate 1 robot, then the other robot now technically gets calibrated to the second robot's position instead of the AsiCube position. So it's easier to kind of just have them both calibrated to the actual AsiCube itself.
Mhm.
I have a question from Nate, who's watching digitally.
Yeah.
He has a question about just pricing in general for the I+ system, or what does the whole thing go together, or is it priced separately?
I+
Any good ranges?
starts at around, or I+ costs around $9,000. That includes the controller, the camera, the lens, the calibration plate. And then the AsiCube sizes start at the smallest. The AsiCube 50 is right around $16,000. And the largest AsiCube 530 is comes in around $28,000. So total system usually costs around $25,000 to $30,000. $35,000.
Did you talk about the production data that you can get from?
Government bill. We have Austin is referencing our I guess I'm lost for words.
The qualification result?
Our qualification wizard. So it's a tool that we've developed for studying your production process. It's also really useful for factory acceptance testing. It basically takes the recipe that you've created and it simulates a production run. So you dump your parts in the hopper. The system starts from no parts on the platform, and you can continue to run it as many cycles as you'd like to collect production data. So how many parts are available per vibration? How quickly does the robot need to move to accommodate your production run rate? And if you start a run, I guess I gotta put the parts on.
Yeah, so we can start a run, take an image, move, perform the vision, and then you'll see your good parts here. And then you would pick all of the good parts off of the platform, place them back in the hopper. In this case, I'll just pick and place them at like right here. And then you can start another run.
Obviously, the more runs you complete, the more accurate your data is going to be. If you have a robot in your application, you can have your robot picking from the platform instead of your hands. And then once you've completed your desired quantity of runs, you can go to the qualification results. And you can adjust things like your robot cycle time if you weren't using a robot. You can adjust your anticipation percentage. I'll click on the little eye. I'm not entirely sure what we even mean by anticipation percentage. Okay. So that would be the time that the robot is moving while that keeps vibrating. So dead time anyways. So you can accommodate things like that and exports a bunch of nice data and graphs that you can share with your management or customer, whoever it may be. Everybody likes to look at graphs.
You can also see a lot of this data too while you're just on the homepage while it's in production. So if you've been running production for an entire shift, you can see, okay, what's my average parts per cycle? What's the main reason that parts are failing? Stuff like that.
So we have a TCP terminal here for you to be able to essentially test different TCP IP commands here. So I'm doing the start production and then our recipe ID command. And it returns 200. 200 is our success code. Otherwise, if it's an error, it will respond with an error code that you can then use. But then production, this is the production state. It'll show you the recipe that you're running. And then if we go back to the TCP terminal and we type in get part, it'll run through. It'll give you a part coordinate and the rotation. And then if we go home, it'll have results. Might take a second to load. But essentially, this would be updated as like a dashboard every time you're in production.
The dashboard can be accessed through the URL.
Yeah.
That you use to access I+, so that can be put on the factory facing HMI. It also tells you your system state. Like I said before, I+ has multiple different system states, so if you're having issues determining why your start production command isn't working, this is a good place to start, just to understand where your system's at, if it's available for production, etc. If it's an error migration, various different states that it can live in. Yeah.
Yeah.
Any more questions? So that's all we got.
Yeah, that's all we got for you guys. Hopefully.